Boeing didn't suddenly forget how to build airplanes. The company still builds some of the most sophisticated machines on Earth, employs thousands of engineers around the world, and carries an aircraft backlog worth hundreds of billions of dollars. So if Boeing can still build airplanes, how did it become a company fighting to rebuild trust in the very machines it creates? The obvious answer is the 737 MAX. 2 crashes killed 346 people, the aircraft was grounded around the world, and Boeing spent years dealing with investigations, financial losses, and a damaged reputation. But the deeper story begins much earlier, because the MAX may not have been the beginning of Boeing's transformation at all. It may have been where decades of decisions finally collided, and to understand why, we have to go back to the company Boeing once was. For much of the 20th century, Boeing's identity was built around engineering. The company helped create the modern jet age with the 707, then transformed long-distance travel with the 747, and established itself as one of the most important aircraft manufacturers in history. Its reputation wasn't built simply by selling airplanes, but by solving enormous technical problems that few other companies could solve. That identity mattered because airplanes are unforgiving products. A software company can release an update when something goes wrong, but an aircraft has to work correctly while carrying hundreds of people through the sky. For decades, Boeing's engineering and manufacturing culture was deeply connected to that reality. But Boeing was becoming much larger and more complex. In 1997, Boeing merged with McDonnell Douglas, creating one of the world's largest aerospace companies and beginning a new chapter in its corporate history. The merger did not magically destroy Boeing's engineering culture, and it would be wrong to blame every later failure on one transaction. But the organization surrounding Boeing's engineers was changing, and over the following years the company became increasingly global and organizationally complex. In 2001, Boeing moved its corporate headquarters from Seattle to Chicago. The company remained deeply connected to Seattle through engineering and manufacturing, but its corporate leadership was now geographically separated from the center of its traditional industrial identity. Then Boeing attempted something even more ambitious. The 787 Dreamliner was supposed to represent the future of aviation, using new materials, new systems, and a radically distributed global manufacturing model that pushed major portions of development and production to suppliers around the world. On paper, the logic was compelling. Boeing could tap specialized expertise, distribute costs, and coordinate a global network of companies instead of performing every major task internally. But the 787 exposed an uncomfortable truth. An aircraft isn't a collection of independent parts, because every part has to become one perfectly integrated machine. The Dreamliner was delayed repeatedly, parts arrived late, work had to be redone, and problems emerged when components created in different parts of the world finally had to work together. The aircraft eventually became a successful product, but its development revealed something Boeing could not ignore. Designing an airplane was one challenge. Maintaining control over an increasingly complicated industrial system was another. And then Airbus created a new problem. The competition was no longer simply about which company could build the most impressive airplane, because airlines were increasingly focused on fuel efficiency, operating economics, and how quickly they could put new aircraft into service. Airbus launched the A320neo, an updated version of its highly successful A320 family. Boeing suddenly faced a strategic choice that would shape the next decade of its history. It could build an entirely new narrow-body aircraft. That would give Boeing engineers a clean sheet of paper, but it would also require enormous investment, years of development, and the risk of allowing Airbus to capture the market while Boeing was still designing its replacement. Or Boeing could evolve the aircraft it already had. The 737 had something no clean sheet design could easily reproduce. Decades of airline relationships, pilot familiarity, maintenance infrastructure, training systems, and thousands of aircraft already operating around the world. The commercial logic was powerful. Boeing chose the second path and created the 737 MAX. At first, the decision looked remarkably rational. Airlines could receive a more efficient aircraft without abandoning the infrastructure they had spent decades building around the 737, while Boeing could compete with Airbus without waiting years for an entirely new aircraft. But that advantage came with a constraint. The 737's basic architecture dated back to the 1960s, while modern engines were larger and more efficient than the engines the original aircraft had been designed around. To accommodate them, Boeing had to make important aerodynamic changes, and that created a difficult engineering question. How could the MAX deliver the performance Boeing needed while preserving the handling characteristics and operational familiarity associated with the 737? One of the answers was MCAS, an automated flight control system designed to address specific aerodynamic conditions. This is where the story is often reduced to a simple explanation about dangerous software, but that misses the decision that came before the software. The deeper question was whether Boeing could continue evolving an aircraft whose fundamental architecture had been designed decades earlier. The MAX wasn't simply a new airplane, because one of its greatest commercial advantages depended on remaining recognizably a 747. That decision connected engineering to economics in a way that would eventually become impossible to separate. Boeing wasn't merely trying to make an airplane fly better, it was trying to preserve the enormous commercial ecosystem surrounding one of the most successful aircraft families in aviation history. Then the system encountered reality. On October 29, 2018, Lion Air Flight 610 took off from Jakarta. The Boeing 737 MAX 8 crashed into the Java Sea, killing all 189 people aboard. Investigators began examining what had happened, and questions quickly emerged about the aircraft's automated flight control systems and the information available to pilots. But the MAX remained in service, and the industry had not yet fully understood how serious the underlying problem could become. 5 months later, another 737 MAX 8 took off. Ethiopian Airlines Flight 302 departed Addis Ababa on March 10, 2019, and shortly after takeoff, the aircraft crashed, killing all 157 people aboard. Now the situation was different. One fatal accident could still be investigated as an isolated event, but 2 crashes involving the same aircraft within months created a pattern that the aviation industry could no longer ignore. The 737 MAX was grounded around the world, and suddenly, decisions that had once looked like technical details became questions about corporate responsibility, certification, communication, and the relationship between Boeing and the Federal Aviation Administration. The question was no longer simply, what went wrong with the airplane? It became something much more uncomfortable. How did an aircraft move through design, development, certification, and commercial operation if the same fundamental problems could contribute to 2 fatal crashes? That investigation led far beyond MCAS. Investigators examined the aircraft's design and development, Boeing's internal communication, pilot information, certification procedures, and the relationship between Boeing and the FAA. The congressional investigation examined hundreds of thousands of pages of records and interviewed Boeing and FAA personnel, whistleblowers, and other participants in the certification process. What emerged was not a story with one villain, but a system in which engineering, management, certification, and organizational incentives interacted. That distinction matters. Complex organizations rarely fail because everyone inside them suddenly becomes incompetent. They fail when reasonable decisions made in different parts of the organization combine into an outcome that nobody intended. One team may be focused on engineering, another on certification, another on production, another on financial performance, and another on delivering an aircraft to an airline on schedule. Each decision can make sense on its own. The danger appears when the organization loses sight of how those decisions interact. The MAX eventually returned to commercial service after an extensive review and a series of required changes. But if the real problem had been only one flight control system, fixing that system should have been the end of the story. It wasn't. In January 2024, an Alaska Airlines 737-9 MAX departed Portland. During the flight, a door plug separated from the aircraft, creating another crisis for Boeing. The airplane landed safely, but investigators discovered that the 4 bolts required to secure the door plug were missing. This wasn't MCAS, it wasn't one of the original MAX crashes, and it wasn't the same technical problem at all. And that difference made the incident even more important. A software system could be redesigned, tested, and monitored, but missing bolts pointed towards something much more fundamental: manufacturing discipline, documentation, inspection, and quality control. Different failure, different aircraft system, same company. Suddenly, the story looked larger than the MAX. If the original crashes exposed problems involving design and certification, and the Alaska Airlines incident exposed problems involving manufacturing and quality control, perhaps the common thread wasn't one aircraft system at all. Perhaps it was the organization behind the aircraft. That possibility became harder to dismiss when an independent expert panel examined Boeing's safety culture. The panel reviewed thousands of pages of Boeing documents and interviewed hundreds of employees. Its findings included concerns about a disconnect between senior management and employees regarding safety culture. And that phrase, safety culture, can sound vague until you understand what it means inside a company like Boeing. Culture is what happens when an engineer discovers something that doesn't look right, when a manager has to choose between production pressure and additional inspection, or when information moves upward through layers of an organization. Culture is not what a company says in a presentation. Culture is what the organization actually rewards, tolerates, and responds to when something goes wrong. And that is why Boeing's crisis became much larger than an aircraft program. The company had to rebuild confidence, not only in the 737 MAX, but in the system that designs, manufactures, tests, and certifies the aircraft. Yet there is another twist to this story. Boeing did not collapse. It remained one of the world's most important aerospace companies, continued receiving enormous orders, and maintained a backlog stretching years into the future. In 2025, Boeing delivered 600 commercial aircraft, its highest annual total since 2018, while its commercial backlog exceeded 6,100 aircraft. The company was damaged, but it was not defeated. And that changes the question we should ask about Boeing's future. The question isn't whether Boeing can survive. Boeing has already survived. The question is whether Boeing can rebuild the organizational capabilities that made its engineering reputation possible in the first place. And one of the clearest signs of that attempt came from an unexpected direction. In 2025, Boeing completed its acquisition of Spirit AeroSystems. Spirit had become a major independent supplier of Boeing structures, including components associated with the 737, and the acquisition brought thousands of employees and important manufacturing capabilities back under Boeing's control. That doesn't prove outsourcing was the cause of Boeing's problems. Global supply chains are not inherently bad, and Boeing's distributed manufacturing strategy produced some remarkable aircraft. But the decision carries enormous symbolic weight. A company that spent years distributing critical parts of its industrial system was now bringing some of those capabilities back inside. At the same time, Boeing's new leadership began emphasizing safety, quality, and closer contact with the engineers and workers responsible for building its aircraft. The FAA has also maintained heightened oversight, while gradually allowing Boeing to regain responsibilities that had been restricted during the crisis. Boeing is therefore not trying to return to 1970. The aviation industry is different. Technology is different, supply chains are different, and the economics of aircraft manufacturing are different. The challenge is harder than simply restoring the past. Boeing has to combine the scale and complexity of a modern global corporation with the engineering discipline that originally made the company exceptional. And that brings us back to the question we started with. How could the company that once defined modern aviation lose control of the system that made its airplanes exceptional? Not because of one merger, not because of one CEO, one software system, or one bad decision. The transformation happened gradually. Corporate priorities evolved, manufacturing became more distributed, competition intensified, an old aircraft became the foundation for a new one, and engineering decisions became increasingly connected to financial and operational constraints. Eventually, those decisions reached the cockpit. Later, they reached the factory floor. That may be the most important lesson hidden inside the Boeing story. An airplane is never just an airplane. It is the physical result of thousands of decisions made by an organization. Every design choice, every manufacturing decision, every inspection, and every conversation between an engineer and a manager becomes part of the machine that eventually carries people through the sky. Passengers see the finished aircraft. They don't see the organization behind it. But that organization is part of the aircraft too, and Boeing's recovery will ultimately be judged not by how quickly it can build more airplanes, but by whether it can rebuild the system that allows people to trust those airplanes before they ever leave the ground. Because Boeing never really lost the ability to build airplanes. The harder challenge is rebuilding the company that builds them. And sometimes, the most important stories in business aren't about the moment a company succeeds or fails. They're about the decisions made quietly in between, when almost nobody outside the company is watching. This is Hidden Ledger, revealing the decisions, incentives, and hidden forces behind the companies that shape our world.